Hi, and welcome to this section of the Basic Math Word Problem Tutor. And in this section, which is going to be our final section, is going to be a little bit different, and the title of it is called Ratio and Proportion. I know you've heard these words before. You may not know what they mean, but I promise I'll explain to you not only what they mean, but how to tackle problems that involve ratio and proportion so you know what you're doing. They're really not that hard. They follow a very specific pattern that's pretty easy to pick up on once you see. I think the easiest way to do it, rather than start talking about a bunch of words and definitions, is to just jump into some problems. So the first one says, if you walk 10 miles in one day, how many miles will you walk in 3 days? Okay, so you see there's three numbers in this problem, and so you really need to be careful about what you do with those three numbers. If you walk 10 miles in one day, how many miles will you walk in 3 days? Okay, so I think what I need to do is to start to write something down and explain it, and then you'll understand. Okay, if you walk 10 miles, I'm going to actually write this 10 miles in one day. Okay, then how many miles will you walk in 3 days? Okay, now I've written a lot of stuff up here, and so it's very important that you understand all of it, so we're going to take it slow. 10 miles in one day. This thing is called, when you have something like this is called a ratio. Okay? What you're really saying is you have two numbers and you're comparing them. It's really the same, almost like a percent. The percent is some number over some number, and that's a ratio. In fact, any fraction is a ratio. It's just comparing two numbers. So don't let the word ratio confuse and scare you when you read it in your book. It just means you're comparing two numbers. These two numbers are completely, unrelated, other than the fact that they're telling you how many miles you can walk in one day. 10 miles in one day. We know they're tied together because that's how fast I can walk. So you kind of put them together in this ratio here, which is basically a fraction, 10 over 1. And I'm writing down what it is, miles in days, miles per day there to help you out. Okay, this is called a ratio. This tells me how fast I'm doing something or what rate I'm doing something or whatever. Now over here, I'm setting it equal to another ratio, but this ratio I have an unknown. I want to know how many miles I can walk in 3 days. Okay, so I don't know what the answer is, so I just put an X here, and don't let that scare you. That letter just means, that's just a letter that says, hey, I don't know what the answer is. I'm going to solve for that. I don't know how many miles I can walk in 3 days. I need to find that. And because I don't know what the answer is, I'm just going to put an X there, and I'm going to solve for it, and that's going to tell me what my answer is. Okay? Okay, so notice how I've set this up. 10 miles in one day is equal to X miles in 3 days. So I have the miles on the top, and I have the days on the bottom. Okay, that's important that you set it up the same way. This is a ratio, and this is a ratio. When you equate two ratios together, it's called a proportion. Okay, what we say is that one is proportional to the other. Okay, and what we say is that this ratio is kind of telling me how fast I can do something in one day, and over here I want to know if this is the case, if this is how fast I can do it in one day, how many miles can I go in 3 days? Okay, so this as compared to this is equal to however many miles I can go in 3 days. So those are equal to each other because these ratios, I'm assuming here that it's the same person, it's me, and I can only walk so fast. So whether or not I walk one day and I go 10 miles, I'm going to be going the same speed as if I had gone 3 days, and I just need to find out how many miles that is. So this is the ratio that tells me how fast I'm doing stuff, and this is the unknown here, X miles in 3 days. So 10 miles in one day is X miles in 3 days. I need to know how to do that. So the good news is once you know how to set them up, they're really not that hard to solve. You need to learn how to cross multiply. When you have two fractions like here, like this, you can just cross multiply. 10 times 3 is equal to 1 times X. So you can do that. Okay, you can do that. So let's cross multiply. Let's start with this one. 1 times X, 1 times X, that's this, is equal to, we're going to cross multiply this, 10 times 3. So you can see the math isn't that hard. Okay, 1 times X, and by the way, X is just a number. It's going to end up being so many miles. I don't know what the answer is. 1 times anything is itself, so I just have X over here, equals 10 times 3 is 30. And remember, X was in terms of miles, so it's going to be miles. So that's the answer, 30 miles. So you see, what it's telling me is, if I can go 10 miles in one day, Then if I can walk for 3 days, I'm going to go 30 miles. Now that actually kind of makes sense when you think about it. If I go 10 miles in one day, okay, then after that first day I go 10 miles, the next day I go 10 more miles, and the third day I go 10 more miles, that's a total of 30 miles. So I go 10 miles, 10 miles, 10 miles, that's 30 miles. So the answer makes sense. The trick is to be able to set up your ratio. Usually these problems are going to tell you, you know, two things are related to each other, and you need to find another quantity. So in this case, it's 10 miles in one day is X miles in 3 days. You need to set it up like this and do your cross multiplying, and you're going to need to set, you know, you're going to need to use X here to because you don't know what it is, and you'll solve for it. In this case, it's 30 miles. So that's really about as complicated as it gets. All of the problems are going to look like this, and in all the cases you'll be solving for X. And if you've never dealt with X before, maybe it looks a little bit scary to you. It's just a letter of the alphabet. You've known X since you were 2 years old. W, X, Y, and Z. Now I know my ABCs, right? So it's just a letter. Don't let it get you all worried because it's in a math problem. It just means you don't know what the number is. And I'm going to solve for that X, and that will tell me what the answer is. So don't get so worried about it just because it's a letter. It's just a letter of the alphabet, okay? If you don't like X, use a different letter. Use A or use K or use Z. Doesn't matter. But X is usually what people use, okay? So the next question says, during exercise, you burn 120 calories in 10 minutes. So that locks the ratio in right there. 120 calories in 10 minutes. How many calories will you burn after 40 minutes of exercise? So this is a ratio question because it tells you 120 calories in 10 minutes. That should tell you that's a ratio. That's how many calories I'm burning in how much time. Then it tells me how many calories will I burn in a different amount of time, 40 minutes. So that's proportion. I'm setting this ratio equal to another. I've got an unknown. I need to find how many calories I burn in 40 minutes. So you just set it up like every other ratio and proportion. I burn 120 calories, and I want you to write the unit down every time or you'll get confused. 120 calories in 10 minutes. That's a ratio equal to, let's see here, X calories. I don't know how many I'm burning. It's X calories in 40 minutes. Notice I've got calories on the top, minutes on the bottom. 120 calories in 10 minutes is equal to, I don't know how many calories in 40 minutes. So it follows the typical ratio and proportion way. Now here I'm going to cross multiply again, okay? 10 times X is just 10 times X. You don't know what to do here because X is some number you don't know, so you just leave it like this. Is equal to, doing this one, 120 times 40. Okay, so what is 120 times 40? Let's do that. I don't know what that is. Let's do it here. 0 times 0 gives me 0. 0 times 2 gives me 0. 0 times 1 gives me 0. Moving on to here, I must put a 0 there. 4 times 0 gives me 0. 4 times 2 gives me 8. 4 times 1 gives me 4. And I add them up. 0 plus 0 gives me 0. Got a 0 here. 8 plus 0 is 8. 4 plus 0 is 4. So it's 4,800. Okay, 4,800. So what I have on the left is simply my 10 times X, because I can't do anything with that, equals 4,800, 4,800 on the right-hand side. So we've done our cross multiplying, and we know that we want to find out what X is because that is how many calories I'm going to burn in 40 minutes. But I have 10 over here, 10 times X. So I have to get X by itself, and then once I do that, I've solved the problem. So notice that here 10 is multiplied by X, 10X. The only way to get X by itself is to divide by 10 because these are multiplied together. The opposite of multiplication is division. Now watch what happens. If I divide both sides by 10, you have to do the same thing to both sides of this equal sign, okay? You divide both sides by 10. Here I have 10 divided by 10, which you already know is just 1. So by dividing by 10, I've gotten rid of those 10s. They've disappeared. They're gone. You're not going to get them again. They are totally gone from the problem. So I've gotten X by itself on the left, which is what I've wanted to do. And that's equal to 4,800 divided by 10 on the right. Okay? So I got X by itself by dividing by 10, but I must do the same thing to both sides, so I divide by 10. Okay, so now the question is, what is 4,800 divided by 10? And then you have the answer. 10 goes into 48, I believe, 4 times, because 10 times 4 is 40. Okay, and then I subtract. 48 minus 40 gives me 8, and then I drop down my next digit, which is a 0. Okay, 10 goes into 8 times, because 8 times 10 is 80. I get a 0, and then I drop down this, which is a 0. 10 goes into 0 0 times. Okay, 0 times 10 is 0, and 0 minus 0 is 0, so there's no remainder. The division stops, and I'm completely finished. Okay, so 10 divided by 4,800 divided by 10 is equal to 480. Okay, so it's equal to 480. So what this is saying is that x is equal to 480 calories, which is the answer. So it looks complicated, but it's really not. You set up your ratio. 120 calories in 10 minutes is equal to x number of calories over 40 minutes. Okay, and then you do your cross multiply. 10 times x is 10x. You can't do anything with that. 120 times 40 gives you 4,800. Now you want to get x by itself, because then you have the answer. And in order to do that, you just divide by 10, because this makes these go away, and 10 divided by 10 is 1, so they go away. So you do this on the right, because you have to do anything you do to the left-hand side of an equal sign, you have to do it to the right-hand side in order for it to be legal. So 4,800 divided by 10. And when we did that, we found it was 480 calories. So if you burn 120 calories in 10 minutes, but you work out much longer than 10 minutes, you work out for 40 minutes, then you have burned not 120 calories, because you are working out 4 times as long. You are burning 480 calories. Okay, you're burning 480 calories total. Okay, the next problem says 40 flowers that you planted, of 40 flowers that you have planted, 10 of them died. If you plant 200 flowers in a separate bed, how many do you expect of those flowers to die? So here you have a ratio and proportion problem, because of 40 flowers that you planted, 10 of those died. So that kind of locks in the ratio. That kind of tells you how many are going to die out of 40. But now I don't plant 40 in the other bed, I plant 200. So I want to know, if the same amount of them are dying, I want to know how many of those 200 will die. More of them should die than in the other bed, because I planted more flowers. Let's find out how many. Okay, so let's set up our ratio and proportion. Of 40 planted, okay, 10 of them died. So I write it like this to keep track of what I'm doing. So in the other bed, 200 were planted. Okay, 200 were planted, and X died. Okay, so notice I have it the same way. Planted on the top, died on the bottom. Out of 40 of them, 10 died. Out of 200 of them, how many should die over here? Let's find out. We cross multiply. Okay, let's go this way. 40 times X is just 40X. 40 times X. I don't know how to do anything more with it, because we don't know what X is. It's just our number that we're trying to solve for. On the other side, 10 times 200. Okay, 10 times 200. Okay, so what is 10 times 200? Well, you probably already know this, but if you don't, 10 times 200, 0 times 0 is 0, 0 times 0 is 0, 0 times 2 is 0. Moving on to this digit, so I put a 0 here. 1 times 0 is 0, 1 times 0 is 0, 1 times 2 is 2, and then adding all of this up, I'm going to have 2,000. So 10 times 200 is 2,000. So I have 40 times X is equal to 2,000. Okay, that's what I have. So we want to find out how many died, which is what X represents. And we want to get X by himself, because once we do that, we have our answer. So since it's 40 times X, we want to do the opposite of that, which is division. So we'll divide by 40 on the left, and then we must do the same on the right. We divide by 40 on the right. Okay? The reason we do that is because when we divide by 40, 40 divided by 40 is 1, so they disappear. So on the left-hand side, all you're going to have is X is equal to 2,000 divided by 40. Okay? So what is that answer? What is 2,000 divided by 40? Okay, what is that answer? How many times does 40 go into 200? How many times does 40 go into 20? Well, it can't go at all, so let's expand. How many times does 40 go into 200? Well, the answer is 5, because 5 times 40 is 200, okay? And you can verify that very easily with multiplication. So we subtract 200 minus 200 is 0, okay? And then we drop down the next 0, giving us a 0. And 40 goes into 0 how many times? It doesn't go at all, so it goes 0 times. 0 times 40 gives us 0. You subtract, you get 0. There's no more digits to drop, you're done. And so the answer is 2,000 divided by 40 is equal to 50. And that's 50 that died. Because don't forget, what we have solved for here was x, which we've tried to say is the number of plants that have died. So if you have a bed of 40 and 10 die, then in a bed of 200, 50 should die. And in both cases, the ratio is the same. 40 over 10 is the same as 200 over 50. Okay, the ratio is the same, and we create this proportion to find out how many will die in the new flower bed. So you see there's a general pattern here. There's a general pattern that they follow, and once you find that pattern, then doing the problems just becomes very kind of mechanical. You can just do it in your sleep, kind of. Next problem says, if it takes 15 yards of material to make 3 Halloween costumes, how much material is needed to make 10 costumes? Okay, so you've got a ratio. It takes 15 yards of material to make 3 costumes. How much material is needed to make 10? So that's a dead giveaway for your ratio proportion. It takes 15 yards to make 3 costumes. Okay, that is a ratio, and we're equating that to how many yards, we don't know, so it's x yards, for 10 costumes. So the question is, if it takes 15 yards to make 3 costumes, how many yards will it take to make 10 costumes? Yards on top, costumes on bottom. The ratio is here, and we're equating it to this one here, and that's called a proportion. So let's cross multiply. 3 times x is 3 times x. You can't do anything with it. 15 times 10 is what's on the right-hand side, 15 times 10. And if you don't remember what 15 times 10 is, you can just multiply it out. Okay? 0 times 5 is 0. 0 times 1 is 0. Moving to this digit, putting a 0 here. 1 times 5 is 5. 1 times 1 is 1, and we add them together. 0 plus 0 is 0. 5 plus 0 is 5. And the 1 just comes down here. So the answer on the right-hand side is 150. 3 times x is equal to 150. Okay, that's all we've done there. Now we must get x by itself, and that will tell us how many yards it will take for 10 costumes. But we don't have x by itself, we have 3 times x. So in order to get it by itself, we divide by 3 on both sides. And what this does is it lets 3 divided by 3 cancel out, because that's just equal to 1. So in every case, we just divide by whatever's in front of x here. Okay, so that means on the left we'll have x is equal to 150 divided by 3. And then we just do this, and then we'll find out our answer. So what is 150 divided by 3? What is 150 divided by 3? 3 times what will give us 15? 3 times 5 gives us 15. So we'll put 3 times 5 is 15 down here and subtract. 15 minus 15 gives us 0. And then we drop the 0 down. 3 goes into 0 how many times? 0 times. Okay? 0 times 3 is 0. Subtract. We get a remainder of 0. There's no more digits to drop down, so we're done. So 150 divided by 3 is 50. So 50 yards is what we're trying to calculate. That's how many yards of material. So if it takes 15 yards to make 3 costumes, then we know it's going to take more material to make 10. It's going to take 50 yards to make 10 costumes. And I hope you start to see the pattern here, that what this is doing is this locks in the ratio. 15 over 3, that's a ratio. 50 over 10, that's a ratio. These ratios are the same. That's why they're equal to one another. And we're using that fact to find out how many yards of material it takes to make 10 costumes. Okay, this problem says on a map, the scale says that 2 inches is equal to 120 miles. So 2 inches on the map is 120 miles. If you see two cities that are 8 inches apart on the map, how far apart are they in miles? So you see, this is a perfect example of how ratio and proportion is used in real life, because in a map, every 2 inches here is 120 miles. So if I measure two cities that are actually 8 inches apart, how far apart are they? So we're just going to use our ratio and proportion here. 2 inches is 120 miles. And we're saying that that's equal to, we found a city that's 8 inches across on the map, and we want to know how many miles that is. Okay? So you can see I have inches on top and miles on bottom. Ratio, ratio. I just don't know how many miles that is, so let's cross multiply. 2 times x is just 2 times x. You can't do anything with it. Equals 120 times 8. 120 times 8. Okay? Now, if you don't remember what 120 times 8 is, we'll just multiply it here. 8 times 0 is 8. I'm sorry, 8 times 0 is 0. 8 times 2 is 16. 6, carry the 1. 8 times 1 is 8, plus 1 is 9. So on the right-hand side, it's 960. Okay? Now, in order to find out what x is, which is how many miles apart they are, we must get x by itself, and the only way to do that is to divide by 2, because that will let this 2 go away with this 2, because 2 divided by 2 is 1. So I will be left on the left with x, which is what I want to solve for, is equal to 960 divided by 2. Okay? Now, what is 960 divided by 2? So we're getting lots of practice with multiplication and division here. 2 goes into 9 how many times? 2 times 4 is 8. So that's as far as it can go. 2 times 5 would be 10. That would be too many. So it goes 4 times. 2 times 4 is 8. 9 minus 1 is 1. Drop down to 6. How many times does 2 go into 16? It goes 8, because 8 times 2 is 16. So we subtract, getting 0, and dropping down 0. How many times does 2 go into 0? It goes 0 times. It can't go in at all. 0 times 2 gives you 0. You subtract, you get 0. Nothing else to drop down, no remainder. There's nothing else to do. So x is equal to 480 miles. Okay, well, let's see if it makes sense just from a big picture. If 2 inches is equal to 120 miles, then 8 inches is going to be quite a bit more in miles, 480 miles. It seems to be about right, 480 miles. We set our ratio up equal to this other ratio with an unknown, cross-multiplied, solved for x, and that was it. So all of these problems really are similar. We're just getting practice with just cranking through it. Next problem says a recipe says you need 0.5 sticks of butter to serve 3 people. If you like to make enough to serve 9 people, how much butter do you need? Okay. The recipe says you need 0.5 sticks of butter to serve 3 people, but you don't want to serve 3 people. You want to serve 9 people. How much do you need? So you see this 0.5 sticks to serve 3 people. That's a ratio, and so we're going to use that to find out how many sticks we need. 0.5 sticks, I'll just put sticks here, to serve 3 people. Okay? And we're going to say, this is a ratio, and we're going to say is equal to x sticks, which I don't know. I don't know how many sticks that is, to serve 9 people. Okay? To serve 9 people. So I've got sticks on top and sticks on bottom. Ratio, ratio. And I'm using this fact that it takes half a stick for 3 people to find out how many sticks for 9 people. So let's cross multiply. 3 times x is 3 times x. I can't do anything more with that because I don't know what x is yet. 0.5 times 9 is just going to be 0.5 times 9. And these parentheses just mean I'm multiplying together. I'm just showing you different ways of writing it. Okay? So, what is 0.5 times 9? Okay? Let's multiply. 9 times 5 is 45. And to find out where that decimal goes, since I'm multiplying, I have 1 decimal here and 1 digit after it. So I have to have 1 digit after the decimal in the final answer. So that's 4.5. So 3 times x is equal to 4.5. Okay? 3 times x is 4.5. And now in order to find out what x is, which is what we want to find out, how many sticks of butter, we must divide by 3 on both sides, because you have to do it to both sides. And then that will let 3 cancel with 3, because 3 divided by 3 is 1. And so on the left, I'll just have x is equal to 4.5 divided by 3. Okay? And that will tell me the answer. Now, what is 4.5 divided by 3? And we're going to use all of our skills here. We're going to use this division. We know the decimal is going to go right above the decimal in the problem. 3 goes into 4 how many times? I think you know it probably goes only one time, because any more than that, it would be too many. 1 times 3 gives me 3. Then I subtract. 4 minus 3 is 1. And then I drop down the 5 for 15. 3 goes into 15 how many times? It goes 5 times, because 3 times 5 is 15. 3 times 5 is 15. I subtract. I get 0. There's nothing else to drop down, so I'm done. 1.5. 4.5 divided by 3 is 1.5. Don't forget x is sticks of butter. Let's see if this makes sense just from a big picture point of view. If it takes 0.5 sticks, which is half a stick of butter for 3 people, and I want to make a bigger recipe for 9 people, I'm going to need more butter. This tells me I'm not going to need half a stick, I'm going to need 1.5 sticks, 1.5 sticks of butter, which seems to make sense because you're tripling the recipe. Okay, the final problem is going to say, if you earn $115 in 3 weeks, how much do you expect to earn in 12 weeks? So you can see it's another ratio proportion problem, because these first two numbers lock in a ratio. I make $115 in 3 weeks. How much do I earn in 12 weeks? So that's a dead giveaway for a ratio. And what I'm going to have is I earn $115, so I'm going to put the dollar sign here, in 3 weeks. That's a ratio. That's how much I earn in 3 weeks. That is a ratio. And I'm trying to find out how many dollars do I earn in 12 weeks. Okay? So I have dollars on the top and weeks on the bottom. $115 in 3 weeks. How much should I earn in 12 weeks? Let's cross multiply. 3 times x is just 3 times x. I can't do anything with it. Okay? And over here, I've got 115 times 12. Now, I surely don't know what 115 times 12 is, so let's just write it down here and find it out. Let's solve for it. 2 times 5 is 10, so I'll put a 0, carry the 1. Okay? 2 times 1 is 2, plus 1 is 3. Okay? Done with that. 2 times 1 is 2. Now I'm going to move to this digit, so I have to put a 0 here. 1 times 5 is 5. 1 times 1 is 1. I ignore this here because that only applied when I was carrying from before. And 1 times this 1 gives me 1. And I add them together. 0 plus 0 is 0. 5 plus 3 is 8. 2 plus 1 is 3. And 1 plus 0 is 1. So it's 1380. That's a big number. 3 times x is equal to 1380. Now, just like before, I want to find out what x is, which is how many dollars. So in order to get x by itself, I'm going to divide by 3. Because then 3 cancels with 3. Because 3 divided by 3 is 1. So on the left, I will just have x. That's what I was trying to do. And on the right, I'll just have my 1380 divided by 3. Okay? So all I have to do is do this division, 1380 divided by 3, and I have the final answer. 1380 divided by 3. Let's see what that is. 3 goes into 1 0 times, so I don't need to do that. Let's look at 13. 3 goes into 13. I think you'll all agree 4 times, because 3 times 4 is 12, which is pretty darn close to 13 without going over. Then I subtract. 13 minus 12 is 1. And after I do my subtraction, I drop down 8. Okay? I drop down 8. Okay? Now, 3 goes into 18 how many times? 3 times what is 18? 3 times 6 is 18. So let's go ahead and show that. 3 times 6 is 18. Subtract. 18 minus 18 is 0. And after I've done my subtraction, I drop down the next digit, which is a 0. 3 goes into 0 how many times? 0 times. Can't go in at all. And then just finishing up, 3 times 0 is 0. Subtracting gives me 0. I have no more remainder, nothing else to drop down, so I'm done dividing, and the answer is 460. 1380 divided by 3 is 460. So the answer is $460. Okay? So let's see if it makes sense. If I can earn $115 in 3 weeks, I expect to earn more money if I work longer. So in 12 weeks, I earn $460, which is what it's telling me, and that makes sense to me. So in this section, we have done problems with ratio and proportion, which are very important, very important topics to understand. The problems are usually going to give you two numbers that are related, and then they're going to have a third number and ask you to find out something related to it. So in this case, it was $115 in 3 weeks. Okay, so now you're not working for 3 weeks. Now you're working for 12 weeks. How much money do you earn? And that's a classic ratio proportion. You're given two numbers to set up what the ratio is, given one more piece of information, and you're asked to find the fourth. And by setting it up here with the fractions and solving for this x that we don't know the answer to, you'll always find the answer using your cross multiplication there. And don't be so worried about it if this x stuff doesn't look familiar to you. X is just something we don't know, and so we're trying to find out what it is. And you treat it like any other number, and then you just solve for that, and that's going to be the answer. So with some practice, I think you can get the hang of ratio and proportion problems using the techniques that we talked about here today.